Hello. So today we're going to talk about significance tests for the difference in proportions, kind of day 2 of this conversation. So one of the things we came to yesterday was that most of the conditions are the same except for large counts. And so the first thing we need to realize is that in order to check the large counts condition, there's 2 ways that you can do that. The first is the way we've been doing it the entire time, which is that P1 times N is greater than N1 is greater than or equal to 10, and and N times 1 minus P1 is greater than or equal to 10, as well as whether or not P2 times N2 is greater than or equal to 10, and 1 minus P2 times N2 is greater than or equal to 10. The other way to do that is to find what's called the pooled C value, okay, or the combined probability. And that's this formula down here, which is x1 plus x2 over n1 plus n2. And you'll see me use that value, okay? And what you'll notice is I intentionally pointed out for us this formula up here. And notice down here, instead of using P1 and P2, or P hat 1 and P hat 2, we're using the pooled value for C. That's one of the biggest changes in this section in terms of numerical differences between the old system and the new system. So let's go on and let's talk and revisit this conversation about prom. Sorry for talking about prom these days, guys. But let's revisit this conversation. So what grade is more likely to go to prom? So let's talk about this. So I pre-filled in a bunch of stuff just to try to shorten these videos a little bit for you. I do apologize. I haven't wanted them to be as long as they are. I'm working on learning how to shorten the videos for you and get to my point faster. So it's still faster than in class though, right? So the student council at a large high school was wondering if juniors and seniors are more likely to go to prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. So that is P hat 1, okay? So P hat 1 is going to be wrong color pencil, Miss B. It's going to be 28 over 50. And P hat 2 is going to be 29 out of 45. And when I do that subtraction, I end up with 0.56 minus 0.64, which is negative 0.08. Okay, and our significance level from the problem, which is already pre-highlighted, which is alpha, that's a really bad alpha, Miss B, is equal to 0.05. And remember, we need a null and alternative hypothesis when we were doing a significance test. So my null hypothesis is always about the population. And what we're hoping initially is that there is no difference in the proportion of juniors and seniors that go to prom. So we would say P1 minus P2 is equal to 0. In the question, it says, do the data provide convincing evidence that a higher proportion of seniors are going to prom than juniors? Which would mean, for my alternative, that P1 was less than P2, or that P1 minus P2 was less than 0, or was negative. Okay. Name the procedure. We're getting really good at this game. There are 2 topics, juniors and seniors. This is a test, and this is proportions. So we will call it a 2 prop Z test. Okay. And our conditions. So here we go with this lovely situation. Is it random? Yes, it is. In this situation, we didn't need random assignment. They're both random samples. Is 50 less than 10% of the seniors? Well, it says juniors, seniors, juniors. Sorry, juniors. It says a large high school, so we're safe. And is 45 less than 10% of seniors? Yes, we're good. Okay. So that brings us to checking for P counts. Okay. So we want to make sure that we use PC instead of P1 minus P2. Okay, so what we're going to do here is we're going to figure out what this number is up here. So we're going to figure out what that number is. So that number is equivalent to, Miss B needs to move her board for a second. Oops, not what I meant to do. Good job, Miss B. Okay. So, PC x1 is 28 plus 29 over 95, which is equal to 0.6. So when we test the normal or large counts, we're going to do 0.6 times 45 and 0.4 times 45. And then we're going to do 0.6 times 50 and 0.4 times 50. And this is equal to 30, and this is equal to 20. And this one's equal to 27 and 18. Okay. So moving on to the mean and the standard deviation. So I pre-wrote in their formula, okay? So we could speed ourselves up a little bit. And this is going to be equal to P1 minus P2, which in our situation, we need to be 0. We're assuming that there is no difference. Okay. And then the standard deviation, this is the interesting part. We have to use that funky formula that we saw up top. This guy right here. Okay, and notice in the numerator we've got p hat 1 and p hat 2 and p1 and p2, but in the denominator we have p hat c's. Okay. There should be p hats. Sorry. All right. Let's go back down and actually write our formula in. Okay. So this is going to be 0.6 times 0.4 over 45 and 0.6 times 0.4 over 50. Okay. And so those numbers work out to be, just for our own sakes, 0 and 0.101. Okay. And so we're going to say that it's approximately normal with a mean of 0 and a standard deviation of 0.01. You're going to start seeing that show up more and more if we haven't already seen that. Moving forward, okay, so if this is 0 and my value is negative 0.08, okay, this is what I want to look for, okay. So I'm going to move down to do these two because there's not a lot of space there for me. Well, actually all three of these, I guess. So I'm going to move down the paper. Okay, and so you can actually see what I write. So Z, which is my test statistic, remember, is equal to the statistic minus the parameter over the standard deviation of the statistic, which for us is equal to negative 0.08 minus 0 over 0.01, which gives me a Z value of negative 0.79. And so from that, we end up with a p-value, right? If I went to my table, I could find that the p-value was equal to, 0.2148. Okay. So assuming the null hypothesis is true, there is a 0.2148 probability of getting p hat 1 minus p hat 2 to equal negative 0.08 or lower, purely by chance, because 0.2148 is less than 0.05. Because the p-value is less than alpha, we reject the null hypothesis. We fail to reject. We fail to reject the null and do not have convincing evidence that a higher proportion of seniors go to prom. Enjoy.